All right, Algebra 1, today we're looking at 4.6, writing exponential functions. And just to be clear, I guess they remind us down here, but yeah, we're looking at this format right here. That's an exponential function in the more basic format. You've got A, which we learned yesterday, can make it a stretch or a shrink. We've got B, which can tell us if it's a growth factor or decay factor. It's going to be exponential growth or exponential decay. And we also learned yesterday to graph these, you just make a table of values. Well, what we have today is we have a table of values, and we're going to work backwards to find out what the equation is. So it's pretty cool. That's how it's going to work today. Now, A is going to be like your initial amount or your y-intercept. We're going to use that to our advantage. B is going to be the growth or decay factor. Growth or decay, depending on if it's bigger than 1 or not. Your growth or decay factor. And that's what we're going to be using here to write an equation. So it says write a rule. If it says to write a rule, that's just an equation. And then they also want to know, is the function growth or decay? All right. So A is the y-intercept. Well, class, if you recall the y-intercept, the x value is 0. To be on the y-axis, your x value is going to be 0. So our y-intercept is right there. So A is 8. And then to find B, which is the growth or decay factor, we got to find out what is going on here. And you can just look at it and see pretty quickly that they're multiplying by 2. Now, if you can't tell that right away, just find the common ratio. Do 4 divided by 2, and you get 2. 32 divided by 16 is 2. You find out pretty quick what's what. Well, our equation here is going to be y equals 8, and then seems like everybody's been liking parentheses there, so we'll do 8 parentheses 2 to the x power, and that is exponential growth. All right, let's try another one. Our y-intercept is 1/4. Now we got to find our b value. They're getting less, so I think it's going to be a fraction. But yeah, 1 divided by 4 is 1/4. 1/4, that's interesting. 1/4 and 1/4. So our equation is 1/4 parentheses 1/4 to the x power. And because it is a 1/4, the numbers are getting smaller. This is decay. Also, you can notice this would be a vertical shrink. This would be a vertical stretch by quite a bit. All right, let's look at our next example. Tell whether the table represents an exponential function or a linear function. And it says if so, write a rule for the function. But you know what? Let's get rid of that if so. Let's make it write a rule for the function, because I think we can do this. I think we can totally do this. If it's exponential, we're going to use y equals a times b to the x. We'll use that. But if it's linear, we're going to use y equals mx plus b. And they're very similar. B is the y-intercept. M is your slope, but it's going to be found by what you're adding or subtracting each time. It's kind of interesting. So we'll work them out either way. On the first one, we've got our y-intercept right away. We're going to be using that no matter what it is. But then we got to tell if this is exponential or linear. And it's tough with fractions. So what I do is I don't even really think about it a lot. I just grab the calculator and test to see if we have repeated multiplication or repeated addition. And so if this is exponential, I'm going to need to do 5. I'm going to find the common ratio. 5 divided by 15 over 2. and I get 2/3. So now I'm going to check. I'm going to do 5 times 2/3. And I get 3 1/3. Well, class, guess what? 3 1/3 is the same as 10/3. I think I can switch it, yeah. 10/3, this works, okay? And then 10/3 times 2/3. Is 2 2/9, which guess what? Oh, whoops, I pressed the wrong button. 20/9. So it turns out, class, our growth factor is, or our decay factor actually is 2/3. So because this is exponential, we're going to go y equals 10/3 times 2/3 to the x. And that's how it's done. Okay, so if it wasn't exponential, we would have found out, we would have did 5 minus 15/2, found out what the common difference is. Okay, so on the next one, so there's our y-intercept no matter what we're doing, but the pattern could be exponential, but you know what, I'm seeing pretty quickly that this is linear. Over here they multiply, but here they're adding 2 each time. That's linear. So this is linear. So what it is it turns out this +2, it's rise over run. +2/1, +2/1, +2/1, +2/1. This is our slope. Our slope is 2. Our y-intercept is 10, so we're going to write y equals 2x plus 10. Isn't that cool? So if it's exponential or linear, you should be able to write an equation for it, a rule for it. If you're not given the y-intercept, you may need to find it. So just kind of leave that out there. All right. On the back, this is kind of interesting. So instead of giving us a table, they give us a graph, and and you're going to be given 2 points. 2 points is all you'll need to figure this out. Okay, so it says first to find A. So yeah, the y-intercept is 10. No problem there. But it says use A to find B. That's kind of confusing. I don't really like the way they said that. So what I'm going to do is I'm going to make a little table here. 0 had a value of 10. 1 had a value of 12. Well, to find the growth or decay factor, just take new divided by old. Let's do 12/10. And that gets you 6/5. Yeah, 6/5 is what they're multiplying by. So we've got what we need. We're going to go y equals 10 6/5 x. Like so. We are in the game. All right, A is 8 on the next one. And then to go from 0, 8 to 1, 4, I can do 4 divided by 8, which is a half. So this is decay, isn't it? It's a decay of 1/2. So it's going to be y equals 8 1/2 to the x. And we are in good shape. Thanks for watching.